Well, since our recording was started, I assume that we don't wait for anyone anymore. And let me present myself. My name is Alina Abed. I'm Senior Test Automation Engineer at EPAM Systems. I have several years of production experience in test automation using .NET. And today I'm going to share some very basic but useful principles with you. And these basic principles will hopefully help you to develop in this sphere if you want to, if you are interested. So let's start. You can actually write to the chat if you ever had any experience with automated testing, just plus sign or something, just for me to realize. Mm-hmm. Mm-hmm. So, okay, was it .NET Automation or Java or maybe some other language? Mm-hmm. Okay, very good. And I also, in my own time, switched from Java test automation to .NET automation very quickly. And I'm still happy with that fact. So maybe if I can give you something new, it would be nice. Okay, let's start with test types we are going to discuss today. In general, we need to talk about what in general should be automated, because to start with is very useful to cover the topic of test pyramid. Because in our hands-on practice, usually unit tests is the lowest level of tests, and usually written by developers. And unit tests are called unit tests because they check the work of the very small and simple object, for example, function, method, so some single unit of code. And if you're familiar with such terms, unit testing is usually white box testing, because those who write unit tests usually know exactly how the code works. And we expect that 100% of code should be covered with unit tests, of course. Every work of every method should be checked and covered. And going further, usually automation engineer have deals with API testing, integration testing, and component testing. As you may understand from names of these testing types, they don't cover only one method or some program unit, but interaction of some components, sometimes interactions of microservices when we implement API automation for some project with different several microservices. And usually we struggle for component and integration tests actually to be API tests, for them to be more fast, stable, easy to maintain, easy to perform and implement. And as many of you from your manual testing experience may be familiar with, we have graphical user interface tests at the top of our pyramid. And at many projects, they are expected to be automated and even included into regression testing. But they are the most fragile, they take the biggest amount of time to automate and are the most difficult to maintain. So today we are going to take a closer look at unit tests. At the next slide, I have just some descriptions, and this chart simply shows us which level of testing is performed by whom. And if you are familiar with terms white box and black box testing, it's like crystal clear that like the lower the level of testing is, the more familiar with application functioning and structure the one who writes these tests should be. And by the way, if you have some questions regarding the topics, you can write your questions to the chat. And if we can give some short answers straight away, I can give it. And if you have more complex questions, we just will discuss them after during our question and answer session. So if you have some questions, feel free to ask them in chat. Mm-hmm. Mm-hmm. Okay. So, and maybe I had answered this question earlier during my speech, but still, why do we need unit tests at all? If you are familiar with such term as quality gate, our 100% passed unit tests are like the first quality gates of all that we may have at the project. So if unit tests for some feature, for example, are not passed, the code of some feature may even not be merged into the master branch, for example, and the feature may not be done. Like the definition of done is not completed because unit tests don't pass. And QA engineers don't waste their time on some trivial defects. It's pretty obvious because, for example, we have some very trivial and simple mistake in some method. It will be crystal clear when our unit tests are failed, and we can see straight away before our code even gets to QA engineers. And of course, defects are fixed as early as possible. Also obvious because the developer is usually the first one who notices these tests are failing. And also high quality unit tests usually serve as a project documentation because they, let's say, in their own manner, describe the behavior of each method, if that's clear. If you have some questions regarding this, please feel free to ask. And if you don't have any, let's dive into the topic of testing tools and frameworks. And let's talk a little bit. If this image is complex and scares you, it's not a problem because I will explain everything. Had any one of you, did any one of you ever used Visual Studio? Community version or professional, doesn't matter. So let's assume that downloading our Visual Studio from official, from Microsoft official site is not an issue for you. And sorry, the tools we will discuss further are usually supported in each edition of Visual Studio, even in Community Edition, if Professional is not included into your software package. And the second question may be, when we arrive to some project as test automation engineer, for example, which platform to choose, for example, .NET Framework or .NET Core. Not diving too deep into this topic, I personally would suggest you to use .NET Core as a brand new project. For example, when you came to some project and you are expected to create automation framework from scratch, please feel free to use .NET Core. And if you are supporting some project which existed long before you arrived, usually people used .NET Framework, but .NET Framework 4.8 is the last version of it. Of course, it's widely used, has a large community, but still, please feel free to look Microsoft documentation. Everything is crystal clear here, but I suggest you to use .NET Core platform. Exactly .NET Core 3. Mhm. And yeah, so usually .NET automation engineers write tests and perform different actions with testing projects using Visual Studio graphic user interface. But we also have a CLI, it's a command line interface. It's even built in the Visual Studio interface. Um, it has terminal if you ever had an experience with it. It's not necessary to know every command line command. sorry, sorry for that expression, but still, it has some short and useful commands. For example, creating project using command line, update, restoring some packages. I may further show you how it works. For example, when you cloning some repository from GitHub, and you can restore some packages just running one command line interface command. So just for information, if any of you ever used command line, maybe not in Visual Studio, but in some other IDEs, please just type into the chat. Mhm. Never. So Microsoft website has like the decent documentation regarding it. If I will not cover any questions that you may have regarding command line interface today, you may look for it later. I may share some links with you. Okay, and well, we have our Visual Studio community or professional, it doesn't matter. And then we need to choose which unit testing framework to use. So usually people start with MSTest framework because it's simply built in. It's built in, and like we have it out of the box with Visual Studio. But for the beginners, it basically doesn't matter. But further, we will discuss some principal differences for unit frameworks. Some, all of them have a big community, and so if you have any questions, any problems using them, you may simply ask them on Stack Overflow or GitHub, and usually there are some ready-to-use recipes, answers to the questions. So there will be no problem diving in pretty fast. So And all packages for using unit testing frameworks can be simply added in Visual Studio using NUgget packages. NUgget packages are some external third-party libraries and tools which you can use in your project in Visual Studio. You may also point if you ever used external packages in your personal or production projects. Okay, I see. So for both xUnit and NUnit is ported from JUnit. So those of you who used test automation is, for instance, Selenium, definitely. So excuse me, those of you who used test automation in Java, definitely familiar with JUnit framework. So NUnit is basically ported from JUnit. NUnit is ported from JUnit. Excuse me. Okay, and further we will take a look at the real very simple but real unit testing project, and what a scary table do we have here. So the main thing about using unit frameworks that you should know is attributes, because attributes is the main thing of use, not the main, but the most obvious for beginners, and the main to learn at the very beginning. So if we need some method, some unit of code to work as tests, it doesn't actually matter unit tests or some other type of test. We need to add attribute test to it. It looks pretty same for each unit frameworks. Please take a look at this table. I will briefly describe some of attributes, and then we will take a look at some example. Basically, we mark test methods and individual tests with attribute tests, and we mark group of tests which are usually placed in class with a test fixture of test class attribute. Not assigned means that unit framework doesn't support such option. And also when we perform a bunch of tests, to avoid repeating some actions in code again and again, we can put some repetitive actions into setup or tear down methods. You may have heard about it because usually, even when we perform manual testing, we need to make some preparations and clean after our actions. For example, delete some instances we created, delete some units we created, whatever. Simply delete objects from our cart when we testing online shopping. And for these purposes, we use setup, teardown methods. In MSTest, they called tests, initialize, and test cleanup. So in this method, we simply perform some actions that we need to do before and after performing each separate test. Usually we need to perform some action between a pack of tests, not performing it before each and every one, but before performing, for example, 10 tests against some features. And for that purpose, we have one-time setup, one-time teardown. Excuse me, I'm reading the examples for NUnit, and you may just trace the other unit tests, unit frameworks attributes. If something is not clear, please answer your questions. We also can assign ignore attribute. For example, if we don't need to delete some tests from the code, but we don't need to perform it for some reason. For example, the feature is intended to be changed but not changed yet. So to avoid failures for a couple of days, we can ignore these tests. Or if something is to be maintained, we can also ignore some. But don't ignore tests when they are simply failing and you don't know how to fix it. It's a very, very bad practice. We can also add a category attribute. For example, if we need to categorize some test or test classes by some features, by some areas. And what else? I actually listed the most simple attributes, not to overload you with new information, especially those of you who didn't have any experience with unit testing before. And if you are interested in learning other attributes, feel free to attend resources with documentation. I left the links at the end of this presentation, and each of these attributes has decent description and is very easy to apply even for beginners. Okay. What else? And there you have just a screenshot, an example of how does our window to look at which tests do we have to perform them, to see their state straight away. It's a test explorer tool. It's like we have it in Visual Studio from the box, and using Test Explorer, you can easily access your tests. I will further show you how we can group tests in Test Explorer. So not seeing them in the plain list, but selecting the tests we need to. By class, for example, by feature, even by absolute path in the solution, and so on. Okay. Actually, I covered the topic of command line interface already. And well, command line interface was introduced with .NET Core 2.1. It's cross-platform, and it's usually used for restoring some packages, building, running something. Like no one expects from you to use a command line for everything. Come on. So if you know how to restore packages, run, build, or clean a project using it, it's enough to pass the interview at least. Okay, let's go further. There you just may see the list of the basic command line interface commands. So you can even create a new project, for example, using it build project, execute some unit test, modify a solution file, and so on. You may take a look at it later. I assume that this presentation will be shared between you. Okay. So let's go further. Maybe if you don't have any specific question regarding these questions, sorry. Okay. And before we jump into writing actual unit tests, let me share with you some best practices, and they are useful not only for unit testing, but for all types of automated tests. Some of you may heard about arrange, act, assort pattern, which is also maybe used in manual testing, because at the beginning we select some data for testing. So arrange everything, all test data, prepare everything, then perform some actions, and then um, check the obtained result. Uh, these checks are called assertions in automated testing. Uh, yeah, maybe it's better to show you magic numbers on some example. And also, your tests should be very simple. For example, if you test some uh, if you test some method, or even not method, or even some feature, your test method shouldn't contain any conditionals. For example, if I don't know, see particular page, then perform assertion. If I don't see, don't. Uh, if your test doesn't like see particular page, it should be failed by some exception. Also, we will talk a bit later about single and multiple assertions. And let's jump like straight to our example. There you can see the simple unit test. Uh, it checks the method of calculator, of some simple calculator which adds two integer numbers. And what can what best practices sorry, we may notice here. This test has a descriptive name which expresses the purpose of this test. So not like check that addition works fine. No, it's terrible naming. Even if you automate some UI cases, also try to choose some relatively short but descriptive names. Also, you may notice implemented arrange, act, assort pattern. At the beginning, we initialize all the data, initialize the instance of our calculator. Yep. Then we perform addition, and then we um, perform assertion, basically comparing the expected result and actual result. Magic numbers is the anti-pattern in automated testing, is when we skip the arrange part and just put 3 and 5 into this add method. Okay, since we test the very simple method here, it's intuitive and obvious. If we have some more complex test methods where some numbers, some values are not that obvious, for example, some, I don't know, 50,000 100 number, which may represent anything, may confuse us in further and our teammates. So every time if you use some numbers or some other types, please also make descriptive variable names. And test is simple. Everything is logical. We don't have any conditionals. And I will show you also some other types of assertions, but it's very good practice to add error messages. At this method call, you may see that we pass a parameter expected result, actual result, and this string is error message, because it will be shown to us in Visual Studio, or maybe included into some reporting tool, and we will know straight away why our tests failed. So it's very useful to use. Okay, it's very good practice to use error messages. So, any questions, maybe? Mhm. Okay, and I understand that without showing some hands-on examples, it's not very easy to, like, I don't know, digest such amount of information. So let's jump into the practical part straight away. So I maybe need to stop sharing my presentation for a couple of seconds and share mm, and share my screen. Mhm. So now you can see the whole screen, right? Please write into the chat. Mhm, mhm. Wonderful. So for those of you who ever had an experience using Visual Studio, the following part will be pretty easy. So um, there we have some very small and simple testing project. I even hesitate to call it a project, but still. So we have a very simple calculator, which has four methods, uh, which just simply adds, subtracts, multiples, and divides integer numbers. So then if I have already added an unit testing a project, but if you may need to edit from the beginning, we go to solution here in Solution Explorer of Visual Studio window. If the Solution Explorer is closed in your Visual Studio, we may edit, open it using View Solution Explorer. It also has some hotkeys, and we right-click our solution and add a new project. Uh, I don't remember from which edition exactly, but Visual Studio has templates for testing project. So we simply type test here, right? And it suggests us different types of testing projects. You may see MSTests project template, for example, a unit test project. Using .NET Core, it suggests me mhm, and xUnit test project template too. So if you are not familiar with Visual Studio, it will be very like you will not be lost here. And for example, let's choose our NUnit test project. Click next. Call it somehow. I already do have one, so like. Mhm. And there we go. As you may see, this project, which was created from template, even has the template class with some test methods templates. And the last but not the least we need to do is to add a reference to our project. You need to open this project node and right click on the item called dependencies, and then click add project reference. And there you may simply click calculator, or if you need to reference any other project, because in on production we usually don't have like only one project in our solution and testing project, but some utilities, database interactions, and so on and so on. Maybe mm, maybe a BDD, project behavior driven, if you may be familiar, but I don't want to confuse you. So let's focus on our unit testing. And there we simply reference the calculator, okay? Mhm. So we may build our solution using F6 hotkey. What do we have here? Built without errors. Okay, fine. So let's leave this one alone. Maybe any questions regarding adding testing projects? I hope that you will easily add, like repeat it by yourself. Oh, following me, fine. Okay. So I already have, I already do have the project template. And as you may see, we use an NUnit framework, and how to actually add not only an NUnit framework, but any other. We need to right click either solution node or project node if you are referencing some package only for this particular project. Okay, let's reference for that particular project, but I guess these packages are added from template. And then we choose manage NUgget packages. And you may already see that we have an unit package already installed and an unit test adapter. If you didn't create a test project from template, for example, you need to add these packages explicitly. Just go and add them. You will not have them straight away, as I do right now. And it's very easy to do. Just browse this tab, and you may see we have, for example, xUnit package here. Our favorite Selenium driver, for example, as I noticed that someone already used it. So any package, for example, if you will follow some courses, any package, any third-party library may be installed there. So any questions maybe? I guess there are no questions. NUgget packages are clear and very easy to use. And then, since we have everything referenced, then let's take a look at this class. Here on the left, you may see that all tests and classes which we have here are listed in Test Explorer. If Test Explorer is closed by default, you can open it by test and clicking test and test explorer. And you obviously see this correlation. Our class in NUnit calculator tests project is called unit tests, and there it is. And we have method called test1. It's a very bad name for a test because it's not descriptive, remembering our best practices. Let's check what we can test and then choose a better name. Mm, for example, mm, mm, for example, mm, s- a subtracting number. How do you think is it good or a bad name? It's descriptive, but it's not bad to be honest. Okay, if no one, mhm, yeah, exactly. Always choose the shorter names, but still descriptive. Mhm. Even this one is a bit better. So then we need to add some arrange, act, assert skeleton. In real practice, we don't add these comments arrange, act, assert. Maybe developers on some project have such rules to add these comments, but I have never seen it. So we need to have arrange, act. If someone is not familiar with C# syntax, it's just comments for it to be more obvious to you which part is respective for what. Hmm. So, sorry. Hmm. Oh, sorry. There you can see that uh, our project should not only target another project here in terms of dependencies. And there, uh, as I showed you, project dependencies, but mhm, oh, I'm sorry. I'm really sorry, but Explaining what happens here. This example is very simple, just to show you how we can test the behavior of exact methods. But here, if someone is not brand new with the simplest with the simplest C#, here we have a calculator class. Like for it to be easier to understand, we didn't put its behavior into any interface or something. So on the real project, it would rather implement some interface calculator, but it would be too complicated for us right now. So here we have just class calculator, which basically just performs different operations on numbers. I just misnamed it, and also let me rename the class. Okay, and going back, as you can see, we using using directive, and it points to our calculator class. So okay, very good. And then when acting, we will do what? Since we are testing subtracting, we will call the subtract method of calculator. If anything is not clear, please feel free to ask, because I'm not familiar with your knowledge of C# or any object-oriented language. So if anything looks confusing, please let me know. And there you can see that we already created an object of type calculator, and here we call it subtract method, and there we pass our test data. Here at the range we have our test data, first number, to subtract from, and the second number which we will subtract from the first. The another good practice is to use simple test data. For example, when we need to test subtraction of two positive integers, don't use, for example, 998 and I don't know, 600. Use remember about classes or equivalents. Since you are all testers, keep in mind classes of equivalence. So here we have our expected result of this method functioning, and then we need to call assertion method. Here in tips, you may see that assert, sorry, mistype, that class assert of a NUnit framework has lots of methods which compare different values in very different ways. So if we need compare some numbers, strings, whatever, we have methods from just equal to greater, smaller. For example, compare if these are collections, do they have any difference or something? So just whatever. Let's look, what do we have here? And here, obviously, we colon are equal, and sorry. Now, please excuse me. No one, no one corrected me. There we also specify the expected result that we specify is also part of arranging. I'm sorry, I just mistyped. Expected result is the result which we expect to obtain, and it's obvious that it's 7, and this one is actually actual result. So sorry for such a pathetic mistake, but actual result is the result of how this function or method actually works, and our expected result is obviously the number or value we expect to get. And at this method, we pass our expected result, actual result, and our like best practices star error message, which, for example, tells us the there we go. And look, what do we call magic numbers? Did anyone notice that I just passed 10 and 3 to this method? And as you may notice, didn't use these ones. It's such simple tests, it's obvious that we're subtracting a 3 from 10, but always initialize variables and pass variables with descriptive names to your methods. So there we're doing what? Subtracting from, so let's suggest different, it doesn't match, but still. So, and what do we have here? Our test methods appeared in our test explorer. Now it has a descriptive name in some way, and let's see, what do we have? We just running it by right clicking and run. As you may see, our test passed. And if we will open output window, it may output anything we write to console. As some of you who are familiar with Java, for example, noticed that here we have console write line setup performed, because for such simple test we don't need any actual setup. I just mentioned just to check that setup was actually called. It's called before test, and tear down is called after test. Do you understand the point of setup and tear down? I think yes. If someone has, maybe. And here in and here in test output, you may see that we have setup performed, tear down performed, and our test passed. How can we break our test? Because sometimes test engineer also fails. For example, like me, when I confused expected and actual, we can, for example, write wrong expected result, and actually it's another way to choose that our test works properly. Okay, our expected result is wrong 8, and if we run the test once again, it fails. And look, our error message is here. It says us that the result of subtraction is different from expected. And it also shows us expected and actual results. here it's our fault, then we need just to fix our test. Sorry. If you need just to jump to some test, just double click it at the test explorer, or if you see the test class in Solution Explorer, just simply click it there. And what else can we do? We can break our code. For example, our code doesn't work well. For example, I did something wrong, and instead of subtracting number two from number one, I decided to add them. And now I'm performing our test once again, and it fails. Why it fails? Expected result is 7, but was 13. And when I see such result, I see straight away that something is wrong with our code, because it's no chance that 10 minus 3 is 13. Then I need to go and take a look at my code and what the hell. Why? Maybe I'm sorry, guys. Maybe because I wanted to show you subtracting number from itself, but started from simple subtraction. Sorry, and it's a very good point to write another test. Now I want add arrange act assert. So subtracting. Also not bad naming, and subtracting number from itself, it's 0. So what test data we may have here? For example, just first number. Also instance of calculator. And subtract just first number from first number. And our assert, we don't need to compare actual result with 0. Why? Because assert has assert 0 or not 0 method, which already compares our result or any value with 0. I guess it's clear. And this method doesn't take 2 arguments and error message, just one value. And here we can simplify our messages. The result is not 0. Not bad. And it appears at our test explorer. We need to rebuild F6. F6 is a hotkey for building a project. And run it once again. It's passed. Why? Because test data is right, and subtraction works fine, so no problem. You can actually copy such a simple calculator class, just to write something that performs some arithmetic operation, okay? Or, for example, download some test classes, test projects from Microsoft related GitHub repositories. I will show you, and just train using methods of unit frameworks, not only NUnit but all others. So is it clear? Also, just to show you a couple of other examples, test method is, I don't know. Test method, it can work without being, I don't know, being related to. Why is there only first number? Because we are subtracting a number for itself, and not to initialize two equal numbers. For example, if I will initialize a second number and it will also be 10. We have just one variable, which value is 10, and we can pass it to times. But what we can do better? It's not practical applicable, no way, but we can write method, for example. Where we pass only one number and if someone else is not familiar with. What do you mean? Yeah, we had another method, sure. I'm just showing you that on practice, i- it's a very low possibility that we will test such a simple method. And that's why, to show how does assert 0 works, I just passed two same numbers to simple subtraction method just to obtain 0 result. And there I just showing you how we can write like different methods for some particular cases, if you will, but it doesn't really matter because it's just an example. So I just wanted to show you other methods of other methods of assertion. And here, when you call these methods, look, subtract number from itself, and there you pass only this one number. It does the same action, just subtract the number from itself. So no matter you call this or that, just the range of this method is smaller because it can only subtract number from itself, but method subtract actually subtracts any positive integer from positive integer. And look. Oh, okay, pass because we and if we, for example, call not 0, look, we have not null, not 0, or not empty for collection. I will show collection. And if we, for example, call not 0, the test will obviously fail. Why? Because our result is 0. The result is not 0, expected not equal to 0, but was 0. Unit frameworks are like already have lots of useful methods just out of the box. And for example, we can, I will show you some example of comparing collection. Here we won't call any methods of some classes, just for example, let it be list. Will be a list of integers, for example, collection of integers numbers. Okay, here we need to add a reference to generic collection. Example 1, 2, 3. 1, 2, 3, and collection 2. For example, 1, 3. And collection 3 is like that. Here we also don't have, may not have any expected result. Just sometimes we can jump into assert like that. Look, let me comment this. Also, we have collection assert, especially for comparing collections. It's very useful for example, UI test automation and API test automation too. For example, when we deal with some rows at the application screen, or with some collections of web elements. Maybe those of you who used Selenium WebDriver definitely had an experience with web elements, etc. When we have the following methods are equal, it compares two collections exactly, not by what they contain, but by the exact order. Look, if we call collect r equal collection 1 and then let's compare. Then let's compare collection 1 and collection 3 are equal, like comparing them exactly, and collection assert. Look, here we have methods are equivalent. It compares collection if they contain exactly the same objects, but they may be in different orders, in any order. You may see that we have hints. It's very easy even for beginners then. Sorry. Oh. And let's run our test. And if I run this test, we have one point to pay attention to. When we write something like that, have anyone heard about multiple assertions? Please, those who has experience with automation in Java. Right. And which assertion of that 3 wouldn't be performed? Of that 3, it would not fail, but not be performed at all. One, first, second, or third. Okay. Look, if we write this, run these tests just as is, comparing two collections, look what happens. It fails. Why? It fails for the second assertion because they have different contents and same contents but in different order. But the test didn't even check the third assertion, because after this one, the first one failed, the test execution stopped. And what can we do to avoid that and to check all of them and like obtain the whole picture? We may use multiple multiple assertion. Mhm. Mm. There we go. We just put our assertions in such construction. You can copy paste it from, for example, NUnit or other sorry, other testing framework documents which you like, also from some examples on the internet. And after we run this multiple assertion, it will perform each and every one assert inside it, like that. Look. What do we have here? As the first assertion, we check that collection 1 and collection 2 are equal, and they are obviously not equal because they have same contents but in different order. Same for 1 and 3, and same for same for 1 and 3, even for equivalent. Why? Because they have different orders and different contents. And let me show you the positive example of collection assert. For example, if we will call equivalent for 1 and 2, because 1, 2, 3 and 1, 3, 2. Are they equivalent? And once again, and there we go. Look, this one is passed, and we have only 2 failing conditions. Why? Because these two are still not equal and not equivalent. And you can also take a look about other methods of collection assert. For example, we can check if some collection contains other collection, or it contains some element. For example, if collection 1 contains a sum of numbers. Maybe some questions regarding assertions. Is it clear how to use assertion methods or something else? I can assume that no questions, right, regarding assertion methods. So just to maybe to repeat, you can have some training or some even read application which was written by you, and add a testing project to it, and like practice writing unit tests. So then I would like to show you, sorry, it's Zoom. I would like to show you a link to GitHub sample project with example of NUnit tests. It's, as you may see, opened for everyone, and it's referenced from official Microsoft website. So I will paste the link to it here. Mhm. And there you can just, for example, clone this repository to you and train adding some unit tests or editing existing tests or something. And let me know, please, if every one of you is familiar with Git, or I need to show you how it works. Please write into the chat. Very good. I think everyone who has even small experience with test automation should know it, so it's not a problem for you to follow this link and look for some to look at some examples. So since you are all familiar with Git and it's not an issue for us today, let me reshare my screen again and we may jump into some question and answer session. Mhm. Sorry. You may write your questions if you have some to the chat, and if you have problems with like writing, please just write down, and our administrator maybe unmute your microphone. Maybe something that you expected to hear today is not fully covered, and I can cover it in a couple of words, or maybe explain once again something that wasn't clear for you. Why I'm happy switching to C#? Nice question. Basically, because most of projects which were suggested for me to work at that time were .NET based, and it's a very good practice to have test automation in the same language, like same programming language for actual application and test automation solution. And the other thing that .NET C# has lots of useful features. Link queue is very useful thing for automation engineer, as I mentioned, working with web automation, like collections of different page elements. Link queue does it, makes it easier. Also, test automation engineers use reflection quite often, and by that time at 2017, if I'm not mistaken, it was very useful to have programming language which supports reflection. I don't want anybody to be confused with this term, but still, if you're interested, Google about reflection and its usage in test automation. And because the community itself is pretty big, and also using third-party tools is easier, and in general, not third-party libraries for Visual Studio only, but some other tools are just more convenient to use in C# for me. But all these things that I mentioned here are more or less regarding unit tests are more or less applicable to Java. And if you're interested in automation in Java, you may dive into that topic, but I'm completely sure. Yeah, it's very important to be fair. Maybe something else regarding some technical aspects. Is it a question? Yeah, current project is my current project is also on C#, which I work on. Your, okay. And are you a test automation engineer actually? I'm sorry. Or are you a manual or a manual tester? You're manual tester. Okay, right. And many like guys who worked as manual testers at EPAM like and urge to switch to JavaScript automation because I don't know why they assume JavaScript as the easiest to learn, but I have some experience. Mm-hmm. Yeah. JavaScript is tremendously popular these days. I have an experience with JavaScript automation a little, and mm, I don't know. Maybe if I had to, I would switch. But I prefer C# because the ecosystem itself is more convenient to work as automation engineer, because automation engineering requires stability and for everything to be clearer and like structured. So if you're looking for switching to .NET automation, there are also many lessons and courses. So if I encouraged you, it's very nice. So as far as I may understand, there are no additional questions regarding that. Okay, and maybe our administrator will then say how we can share our presentation, because I have several yeah several useful several useful links, but I don't know what happened. Yeah, here it is. Just missed them. I have useful links to some sources which I partly used in my presentation, and which can like easily help you to maybe fill some gaps which you may feel after that presentation. So after it's shared, actually, as my very first project, I used MSTest, but this project was not production, but more or less, how to say, it was like a student work, like coursework or something. Mm, but actually, NUnit is widely used for Selenium automation, for web automation, because I personally work at web application automation, and xUnit is also widely used, but MSTest is I have experience with MSTest, but it's lower possibility that you will use it somewhere on the project. No, didn't use. Let me Google it. What is it? You see, there is something for me to learn also. We'll take a look and we'll take a look at it. Okay. But it's okay. It's really common at projects with web automation and behavior-driven testing, like spec flow. If you are familiar with this, usually NUnit is used, because NUnit like supports parallelization. It has very like intuitively understandable attributes. Okay, and there are many ways to arrange, and also I don't want to confuse anyone, but attributes are also extensible. So for example, if you need to add some custom attributes for your test automation project in unit, you can also do it. But test and test case attributes are not extensible. Actually, I'm sorry, I lost the chat. I lost the chat. Here it is. If you ever worked with types extension, if someone worked with types extension, so basically in C# you can extend any class, any type with some like additional features. The same thing you can do with attributes, since they are all like classes. And I also said, did I say that our tests? Oh, okay, nice question. It wasn't meant to cover it here, but okay. Usually we, since the programming work itself becomes more and more iterative, also writing new framework from scratch is iterative too. So from the very beginning, we write our framework skeleton. Let's say that we have a web application, and where is actually drawing whiteboard? Oh, fine. Look, from the very beginning, we have our core layer. Core layer of our framework, which includes, for example, Selenium WebDriver, or some API interaction classes. Also here we have different driver factories and browser factories. So from the very beginning, the first iteration is to make the skeleton to have core. Then we go to our, for example, if it's web automation, it's usually a page object layer. Are you familiar with page objects pattern in test automation? Look. So before writing any tests, we need to have this skeleton. So after we implemented core, then we have page object layer. Since like page objects and their elements need to interact with WebDriver. So page object is interconnected with WebDriver, and then we may have a layer of, let's say, utilities, which may, I don't know, maybe generate some, how to say, some units, to maybe some data, to make some preparations, whatever. Also, some use cases are included here. You may know the difference between different page methods and use cases? And like the highest level is our tests. So sometimes when automation is not included into the into the definition of done, and we have some time to prepare the framework skeleton, it's implemented like that: core, page object, and also I would like to mention that these layers interact only with page objects, and they don't know anything tests, and utilities usually don't know anything about core, like open closed principle, solid, all that stuff. And tests interact with use cases and utilities, and sometimes when there is no other choice, with with page object layer. Sometimes, especially when there is no behavior driven testing, sometimes they call straight our page object methods. And we also, last but not least, we have a data layer. Maybe some database interaction or something. Like that. And yeah, and if you are familiar with behavior-driven development, actually our tests layer is feature files layer with like human readable test cases. And then like we have two test layers, like these feature layers and step definition layers. Yeah. If you are interested, I may add you a link to SpecFlow. Does anyone of you have experience with behavior-driven testing, by the way? You're not. So I don't want to confuse you actually, but if you are really interested, I may add just a link to SpecFlow.org for you just to take a look. It's like an extremely useful thing in automation these days, and it's used on more and more projects. So is this chart like clear? Can you understand? Okay, okay, nice to hear. So maybe anything else? What do you want to know about driver factories? Because if you just want to hear how to implement driver factories, there are lots of like tutorials, but in a couple of words, if you want to hear the principle of driver factories, or what, or where exactly it is placed in our automation solution. Okay, driver factories. Okay, why do we need browser factories? When in our automation project, we use several browsers, for example, Chrome, Firefox, whatever, and we say to our browser factory, please return me an object of, for example, Chrome or Firefox. And same with and this is exactly the same, because for like how to say, for each browser we need its driver. Okay. For example, Gecko driver for Firefox, Chrome driver for Chrome. So we just tell to that factory instance of which driver to return. So if we use Firefox, please return us an instance of Gecko driver. If we use Edge or something, please return us an instance of driver for Edge. Is it clear or what? Because basically, driver is just what Selenium uses to interact with our web page. So we need some specific driver for specific browsers, and then it needs to return us some browser instance to interact with it. There are lots of actually examples on the internet. So okay. Thank you very much. Thank you guys for attention. If you don't have any other questions, maybe we can wrap up. Thank you, Irina. Thank you. Okay, I guess the presentation will be shared. Thank you, Жанна. So then, again, thank you all very much and have a nice evening and goodbye.